Welcome again, Wildcats. All right, so if you're turning into this video, you'll see that the table of contents looks different. Well, I was reflecting and I came upon an idea that I think is a good idea. I think y'all like well, we have 6 weeks. Well, the first 6 weeks, that was our first page of table of contents. So now we're into the second 6 weeks. Let's have a table of contents just for the second 6 weeks. Okay, so that's what we have here. All right, and so the first assignment for that 6 weeks is on Thursday, September 29th, and we're going to be graphing systems of equations, and it's going to be on page 16. So if you would, pause the video and update your table of contents. All right, now that your table of contents are added, updated, let's go ahead and turn to page 16. All right, so here we go. All right, so what you'll see here is, first off, you should see some colors. So what I would do is probably pause the video, either run around your house, find some color pencils, crayons, or whatever it is, or run to Walmart, HEB, wherever you find supplies the best. I'm from Texas, so I prefer HEB because there everything is better. But nonetheless, I'm assuming you paused the video, you ran around, got some color pencils, and now you're back. So let's look here. So today we're looking at graphing systems of equations. All right. And before we do that, we should probably review some of the forms of equations. And the first one is standard form. Okay. So standard form is ax plus by equals c. All right. Now, I'm going to show you a trick using standard form to find the x-intercept and y-intercept. Okay. Now, if it's an x-intercept, the y value is 0. So I'm going to use my thumb here as a 0. So y is 0. As we know, 0 is nothing, so we can get rid of it. Here, so now we're left with ax equals c. Well, if we divide both sides by a, we have c divided by a, and that is the x-intercept. Okay. Now, if it's a y-intercept, the x value is 0. So we're going to cover up x as a 0, and now we're left with by equals c. Well, if we divide both sides by b, we have c divided by b, and that is the y-intercept. Also, just a note, I'm not going to walk you through how to get it, but just a note that the slope is negative a divided by b. Okay. The next is slope-intercept form, okay, which is y equals mx plus b. It's called slope-intercept form because you have slope and you have the y-intercept, thus slope-intercept form. Okay. Important to note is the slope is in front of x and the b is right here. Okay. Then the next one is point slope, which is y equals, or not y equals, y minus y1 equals m parentheses x minus x1. Well, you notice it's point slope because you have point x1, y1 and slope m. Okay, so there's your general equation forms, but there is two more. When y equals a number, it's a horizontal line, and x equals a number, which is a vertical line, which I almost forgot, but these are going to be important, especially if you look at the assignment, you'll notice that this concept will be important on one problem, at least one problem. All right, now let's move on to the types of systems. All right, so there's three types. There's one solution when two lines intersect. There's infinite many solutions when the lines are the same line, and there's no solution when the lines are parallel. Okay, well, if it's one solution, it's independent and consistent, and there's different slope. Okay, that means each of these lines have different slopes. Now, if it's infinite many solutions, it's dependent and consistent, and they're the same line, which, since they're the same line, there. And if it's no solution, it's inconsistent, and they are same slopes. Okay. Now, what I want you to do is come to class, and I want you to look up what it means to be consistent and independent, and dependent and consistent, and inconsistent when it comes to types of systems. And then we'll have a class discussion about what you found. Okay. All right. So if you would, pause the video and update your notes. All right. So now you've updated your notes. Let's look at the examples. All right. So first off, these are going to be again on page 16, and you're going to tear off your examples, and you want to hole punch them. So once you're done with the examples, you're ready to put them in the journal. All right, so let's look at example 1. All right, example 1. First, before we graph, you'll notice that we need to distribute the 2. And that's why I've left you space here to do some work there. So if we distribute the 2 in the first equation, you get y equals 2x minus 2. Now, the number in front of x is slope, and slope is a fraction, so we're going to put the divided by 1. And you know 2 divided by 1 is still 2, so we haven't changed this, we just have here now, so we have slope. Well, slope is rise divided by run. And we know from the notes that this is slope-intercept form, and this is the slope, and this is the y-intercept. So we're going to start at 0, negative 2. And then from there, we're going to use the slope. So up 2 to the right 1, 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 up 2 to the right 1. Now draw up. All right, now you'll notice, first off, we're going to put a 1 in front of the x. If there's not a number in front of the letter, put a 1. Okay. Now you'll notice that this is standard form, and I taught you the notes about the x and y intercept for this reason. Now we're going to first find the x-intercept. So we're going to, I think my thumb is too big. So here we're going to cover up the ratio. The ratio is 0, so y is 0. So that we have x equals negative 8. So that point is the x-intercept, which is negative 8, 0. So let's go ahead and plot that point. So negative 1, 2, 3, 4, 5, 6, 7, 8, negative 8, 0. Now let's find the y-intercept. So when it's a y-intercept, x is 0, so we cover up the x, and we solve for y. So we divide both sides by negative 2, which 8 divided by negative 2 is 4. So our y-intercept is 0, 4. So we plot that point. So 1, 2, 3, 4. Now you know if you have 2 lines, or 2 points, you have a line. So we're going to connect our points. It's very important that you use a ruler. Now we have the point of intersection, which is 1, 2, 3, 4. 1, 2, 3, 4, 5, 6. So your solution is 4, 6. And make sure you write the solution. I think that was one of the problems on one of your assignments is you forgot to write the solution. So you don't want to write the solution. The solution is 4, 6. All right. So let's look at example 2. All right. So example 2. Now you'll notice here, and I'm going to rewrite it so I can put the slope. Okay, just to emphasize that 1 there. So this is slope intercept, so we have the y-intercept, which is 0, 2, so 1, 2. And then we know our slope is negative 3 to the right 1. So down 1, 2, 3 to the right 1. 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 All right. So now let's graph the second line. Now, I'm actually going to erase this because I actually want more space to work with this, okay? All right, so first off, you notice the minus 20. Well, we want to convert this to standard form, so we're going to add 20 to both sides, and I'll show you why we're going to convert to standard form in just a second. So negative 20 plus 20 is 0. So you get 6x plus 2y equals 20. So now we're going to use a trick to find the x and y-intercept. So here, so to find the x-intercept, we're going to cover up the y and solve for x. Now what I want you to see is 20 doesn't divide into 6 evenly. So meaning you're going to get a decimal. Well, decimal doesn't help us when we're graphing with this. And this problem was done intentionally so you can see that, yes, that trick is nice, but when that trick fails, you can always solve for y. okay, and put it in slope-intercept form. So that's what we're going to do. So to do that, we're going to subtract 6x from both sides. So 6x minus 6x is 0. You get 2y equals 20 minus 6x. We're going to now divide everything by 2. And so then you get y equals 10 minus 3x. And we're going to go and put a 1 underneath the 3. Now with slope-intercept form, we have, wait for it, my phone is ringing. I'm going to answer it because it's my wife and I don't want to get in trouble, so I'm going to answer it. Hello? Yes, I'm actually making a video right now. Can I call you right back? I'm making a video for my class right now, so can I call you right back? All right, love you too. All right, my wife knows of my love to her, so now I'm going to continue the video. All right, so here we have, it's written a little differently. So you can actually graph this because this is still slope and this is still the y-intercept. But if you're kind of uncomfortable, oh, don't feel good about this, you can rewrite it as y equals negative 3x divided by 1. That's a positive 10, so plus 10. So either of those forms is correct. Okay. So either way, we're going to start at 0, 10. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. And then our slope is negative 3 over 1. So we're going to go down 1, 2, 3 to the right 1, 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 down 1, 2, 3 to the right 1. All right. And you'll see that these lines are parallel, so it is no solution. All right. So I feel like by giving you example 1 and 2, I've given you really diverse examples, and I think it's fair to leave you example 3. So I want you to try example 3 now. Okay, now try it. If you get stuck, we're going to go over example 3 in class. Okay, so I believe that covers what we need to get covered. And I also believe that I need to really call my wife back. So we're going to end here. And as always, I want you to know, have a terrific Wildcat day.